Hey guys, some people came up to me after class and asked me to explain a little bit more in detail about what is happening with hypoxemia in terms of the AA gradient. So this is kind of my little explanation here. What we have going on, we have the causes of hypoxemia up here, and one of the first ones that we went over was hyperventilation. Hypoventilation. That's hypoventilation. And so what we have here is we've got a normal alveoli right here, an alveolus. And if you're hypoventilating, right, you're not ventilating as much, that will cause your alveolar PO2 to decrease. So I've got right here from 100 to 90. So it's decreasing from 100 to 90 right here. And it's not going to affect the AA gradient. Hypoventilation does not affect the AA gradient because instead of 100, you have 90 here. So we have 90 right there. Well, that means that the blood, and this is representative of the capillary blood that's leaving the pulmonary capillaries, it's going to equilibrate to 90 as well. Now, realize that that 90 will, travel down here, and then we have the contribution of our right to left shunt down here, and I've represented that with like sort of a negative 10 right there. So that will actually cause a drop in the PO2 of the blood to to 80. I have right here because it's 10 right here. I'm just using these numbers just for simplicity's sake. So we have equilibration of the alveoli with the pulmonary capillary. Therefore, that 90 is coming down here, and it will now be diluted, if you will, with the shunt blood, the right to left shunt blood, and therefore you have an 80 as the arterial blood. So what we're doing is we're essentially going from 90 to 80. That difference is 10, right? So that's a difference in 10. Well, in a normal lung, you've got 100 up here. Right there, you got a PO2 of 100 there. It equilibrates with the blood that's going through there, and you still have the contribution of the normal right to left shunt, which I have represented here by negative 10. So you'll go down to 90. Okay, so if we look at the comparison between the normal alveolus and the normal arterial blood, that's going to be an AA gradient of 10, and that's the same thing that we see here with hypoventilation. We're just moving the numbers down a little bit. So instead of 100 in the alveolus and 90 in the arterial, we've got a 90 in the alveolus and in the arterial blood, our pulmonary capillary blood, and then we've got an 80 here. So once again, there is no change in the AA gradient because both of them are 10. Does that make sense? Okay, cool. So let's go on to the next one. So this is diffusion impairment. This is an example of it. And when we have diffusion impairment, diffusion obviously becomes an issue in the alveoli or in the lungs. And so what we have here is we've got a normal PO2 of 100. So we're going to draw 100 right there. But now, because we have a diffusion impairment, we don't have equalization of the blood that is, coming into the pulmonary capillaries. It's not equaling the alveoli. They're not equilibrating as the blood runs through. So maybe you've got 100 PO2 in the alveoli, but really you've only got 90 in the blood, the pulmonary capillary blood that's leaving the lungs, okay? And then we have our normal contribution of our right to left shunt, and we're going to put there as negative 10. So now we take 90 minus 10, and now we're down to 80, okay? And so this AA gradient, if you look at the difference between the arterial blood and the alveolar blood, 100 and 80, that's now 20, right? So the AA gradient, we saw a normal up here at 10, right? A normal is 10. We're just saying that number. Now the AA gradient we're saying is 20, okay? So that's a diffusion impairment. So a diffusion impairment will increase the AA gradient. All right, let's look at let's see the next one. The next one is a VQ mismatch. Okay, so this VQ mismatch is a little bit different, okay, and it's a little bit different because with the VQ mismatch or a low VQ ratio, what's happening is, let's zoom in here, is the majority of the lung, 90%, right, that's what I have circled right here, 90% is functioning normally, right? So you've got normal equalization of the blood that's coming in. It's going to be reaching 100 and then going down. But what happens with a low VQ ratio area is that we'll say maybe 10% of the lung has got a low VQ ratio. That means that 10% of the alveoli aren't being ventilated very well. So instead of a normal 100, maybe this only has 90 in there. Okay, so the blood that's passing by this low VQ ratio alveoli is only getting only getting a PO2 of 90. And so then when you take, let's go a different color, when you take the 100 right here in the normal, but then you're adding a little bit more blood, but it's only 90 right here, then that's going to decrease the total, we'll say, to 95. And then don't forget, we've got our normal VQ, or our normal, right to left shunt. We're going to say that's a 10 right there. So now we're going from 95 down to 85. Do you see that? So the ratio here, or the AA gradient, would be you're taking the 85, and then you're also taking the majority of the lung, which is sitting at that 100. So if we're doing that, then that's going to be a 15, or an AA gradient of 15, which is greater than the normal. So when in a VQ ratio, when you have a low VQ ratio, you're comparing it back to what the majority of the lung is undergoing, which is 100, but just a portion of it is kind of acting like its own right to left shunt. Okay, does that make sense? Okay, so hopefully that makes sense. If not, let me know via email. This was just a test. And then obviously the last one was a right to left shunt, right to left, right to left shunt. And a right to left shunt is going to essentially do the same thing. So we've got our alveolus here. It's going to be a normal alveolus right there. We've got our blood coming in, our blood coming down. We're going to draw it right here. And then we're going to do this. And then, so our right to left shunt would be here. So if we've got, it's going to equilibrate 100 right there. It's going to come down there. But now, instead of our right to left shunt being, say, we've been having the example of -10, but say it's not -10 anymore. Say we're going to put, maybe it's -15, right? And I'm saying negative just because it's going to decrease the PO2 of the O2. So say our right to left shunt is increased. So it's going to go from maybe a -10 to a -15. Therefore, now we have got a final of 85 here. That should be an 85 there. Does that make sense? Okay. So remember, the right to left shunt is essentially when you've got venous blood coming in and mixing with the arterial blood. That's arterial blood here. That's going to decrease the overall concentration or overall partial pressure of that blood in the arterial system. So right to left shunt will also widen or increase the gradient. Okay, so real quick, just to sum up what we've gone over: different causes of hypoxemia. We've got hypoventilation. We said hypoventilation is not going to change the it's not going to change the AA gradient. It will, obviously, you will change the numbers, right? You're going, instead of from 100 normal to 90, now you're going from 90 to 80. Okay, so it's not going to change the AA gradient. Diffusion impairment will change the gradient because you are oxygenating less. You're not getting equilibration of the actual blood with what is in the alveoli. And so, therefore, you add the contribution to the normal right to left shunt, and you're down to 80, right? So now that AA gradient's increased. A VQ match, where you have areas of low VQ, what you're doing is you're basically adding in partially oxygenated or low oxygenated blood into that, which will bring over or bring down the total PO2 of the arterial blood. And these numbers, we just we kind of use that. So, but either way, whatever numbers you use, it's going to decrease the overall alveolar to arterial, it will increase the alveolar to arterial AA gradient. So that's the AA gradient. That's the difference between the alveolar and the arterial. So we got 85 down here for the arterial, and the alveolar is 100 up there. Okay, and then finally the right to left shunts, which we went over as well. With these right to left shunts, you've got your you just have more of a contribution of the right to left shunt, and so if you have more of a right to left shunt, you're going to decrease the arterial PO2 even greater, so that a right to left shunt will you're going to increase your AA gradient. Okay, guys, hopefully this was helpful. Hopefully it answered more questions than it spawned. Let me know if you have any questions. Email me, message me, like this video. Haha, just kidding. We're not on YouTube here. But as always, stay cool, stay in school, and don't do drugs. #Nancy Reagan. Just say no.